Welcome, welcome friend, to this Jesus Amen Creation Corner study, focused on the amazing properties of water. Before we begin, some background on the Creator Jehovah's de facto dynamic that drives nature's systems and their subsystems, and causes them to manifest the behavior and patterns that we observe in the universe around us. Our universe consists of interrelated systems and their subsystems, and each is guided by a peculiar rule-based algorithm particular to its function in the universe. For example, if a human being were the so-called system, then that person's arm would be a subsystem. And in turn, an arm is comprised of subsystems, like for example tendons. And no less tendons are comprised of subsystems. For instance, a collagen fiber in a tendon would be a subsystem, and so forth. Consider the Earth as a system. Then we would consider this hierarchy of systems and their subsystems. Earth, subsystem, lake, subsystem, water, subsystem, hydrogen, and so forth. Proton, quarks, gluons. So let's drill down a little bit. All systems in nature continuously query their immediate environment at every instant and immediately update themselves according to Creator-imparted rules that are particular to their role in the system to which they belong. These rule-driven updates determine a given subsystem's response to stimuli coming from its environs, that is, from other systems and their subsystems, over against the current state of the given subsystem. What we mean is that the rules are coded around both, and that is the key word, both the instantaneous state of a given subsystem and the stimuli it receives from outside the system to which it belongs. The instantaneous state of a subsystem and the stimuli it receives at every instant. These are the input side of the subsystem's rules. This is a query block right here, the query block. And the subsystem's response based on that input is the output side of the rules. It's the output side of the rules. Now, it is understood that a given subsystem has the a priori mass, energy, charge, spin, and whatnot, currency to respond to said stimuli entirely in accordance with its inherent rules. We hold that is why our universe is of necessity constrained by conservation laws. It is precisely because the Creator's bank does not have a revolving door. The currency that is circulating amongst the universe's subsystems has been efficaciously fixed by the Creator. Now, a subsystem's response may manifest in different ways, but generally 4 patterns emerge in nature, in keeping with studies published by Dr. Stephen Wolfram. And in order of increasing complexity, we have this. We have uniformity, This is a uniform pattern. This could be uniform color as shown, excuse me, as shown here, or a uniform texture, and so forth. Other practical examples of uniformity would be like, say, hair color, or multiplication by a constant, or the dimensions of a cube. And then next is repetition. Here we see various examples of repeated patterns in nature. A sine wave, a crystal lattice, stripes on a zebra. Another example would be heartbeats, for example. And then there is nesting, nested patterns. Here we have self-similar or fractal patterns, where what we see here is this large right triangle is enfolded in itself. Here's another right triangle. Let's pick this one. Okay. Inside that one is another one. Inside that one is another one, and we could go on and on. That's the idea. And this stacking of the bird's nest here shows the idea. It conveys the idea of a nested pattern. In this category belongs subdivision. Notice that this pattern tends toward a striped pattern, like stripes on a zebra. The white and the black alternating like that. And we would see this much more clearly even if we had more steps and showed the pattern, a larger pattern of it with more steps. This is a rule. Here's the rule. It's a very simple rule. It says that a black block, like for example this top black one here, is supposed to go to a white-black block. So this large black one here goes to this white one, and then this black one. And a white block is supposed to go to a black-white one. So then this white block on the next step goes to this black-white one. This white one goes to this black-white one, and so forth all the way down. It's a simple rule. It's one sees the blocks getting smaller, so there's a change in the color, but the blocks themselves are getting smaller as one moves down the pattern, but the size never attains zero. It just keeps subdividing down. This is the idea of subdivision. You never really reach zero size in this case. So yes, it's a simple rule, but a very interesting result. And indeed, Jehovah's rules in nature do appear to be simple, but the patterns and attendant functionality that emerge may not be so simple. Form follows function, and that's the idea. It is efficacious simplicity on display in the universe, which in itself is consummate elegance, and certainly this is to the Creator's glory. Oftentimes, human models of God's universe complicate Jehovah's elegant creation, particularly those models based on differential and integral calculus, which stumble over nonlinearities. Yet, nonlinearities are the norm in Jehovah's creation. Discrete computation does much better here. This pattern, this subdivided pattern, for example, is a discrete pattern. It's a discrete feedback pattern, in fact. One would not want to model it with a differential and integral calculus, even with a computer at one's disposal. It could be done, but it can be done much more straightforwardly, discretely. And here we have now finally complex patterns. This is air turbulence, a very complex pattern. Other examples of complexity would be water turbulence, for example, whirlpools, or an operating system's causal network, for instance, would be a very complicated pattern. Or the thought patterns attending human consciousness is certainly a complex pattern. And we're going to play a video here of water boiling, which is another very complicated pattern. This is based on a feedback model. And the code, it's a Mathematica code, is in the appendix for anyone who would be interested in that, which we'll show later on. In essence, the gases of the water are escaping and will be shown to create the typical, common, a very familiar bubbling phenomenon as this thing works itself out. Nature manifests these patterns that we've just shown: the uniformity, repetition, the nesting, the complexity, either distinctly or in combinations of one or more of them. One need but look at the world around us to easily spot them. And nature does this via a query, update, response, repeat mechanism, which is precisely a feedback mechanism. Feedback operates incessantly at all levels, from atomic scales to galactic scales, in all of nature's subsystems, without exception. Though it is not always negative feedback, oftentimes we witness instabilities in nature that can usually be traced to positive feedback at work. So if we're to believe, for example, that our universe is expanding, that is a classic example of positive feedback at work. Okay, let's move forward here to that discussion of the feedback loop. This picture we showed previously, but now we have labeled the various blocks. So this is the query block, the input side, the rules, the output, and the update. The system is in one state. The rules cause it to update and move to the next state, and the response to the outside world. Okay, so as concerns our subject, water is a vital and not surprisingly ubiquitous subsystem of nature, and it is of great importance to all of life. In a human being, for example, nearly 60% of an adult's body is comprised of water. Consider these subsystems with respect to water. The brain and heart are comprised of approximately 75% water, and the lungs are approximately 80% water. Water consists of inherent rules that the Creator Jehovah coded into it, not least into its hydrogen bonding, which we're going to talk about, so as to serve its function in the mosaic of systems and their subsystems, living and non-living, that we call nature. And we're going to selectively examine some of water's rules in this summary study with an eye to water's place in the Creator's overall design of the natural world. Okay, we're going to limit our study of water to these several rule-based and feedback-driven properties of water that Jehovah God coded up and made functional and placed into his mosaic of systems and their subsystems that we call nature. We're going to look at the temperature-density relationship of water. We're going to look at the hydrogen bonding and the fallout that comes from that. We're going to look at its acid-base or amphoteric quality. We're going to talk about a blood buffer in the human body. And then finally we're going to look at water and the cell. Water has an unusual temperature density behavior between the very precise temperatures of 0 degrees C, which is 32 Fahrenheit, and 4 degrees C, which is 39.2 Fahrenheit. This is uncanny and bespeaks purpose and design in the extreme, which we hope to show as we go along. The surface layers of a large body of water will cool and sink when exposed to a frigid ambient. They sink with water's maximal density of 999.96 kilograms per cubic meter. At a temperature of 4 degrees C. It's this guy right here. At this maximum density, we have an unusual, tightly packed, shrunken, if you will, liquid phase. And for temperatures on either side of 4C, in one direction cooling, this way, and in the other direction warming, water suddenly becomes less dense, irrespective of the trending of the temperature away from the 4C tipping point temperature, which is quite uncanny. A less dense liquid phase bespeaks a less tightly packed molecular arrangement, with attendant expansion as shown by the curve. Then, amazingly, the lowest density is attained upon transition to the solid phase at 0 degrees C, which is this right down here. The orientation of water's hydrogen bonds, which we will discuss later, causes the molecules to push farther apart in the solid phase. Thus we have maximal expansion of the molecules right here and lower attendant density. And hence the solid phase, the ice, floats on the slightly warmer and denser liquid phase just below. And of course, denser water sinks. So the temperatures of the lower portions of a body of water further down under the ice will equilibrate at the slightly warmer 4C temperature. So yes, it is true that the water is slightly warmer beneath the ice, but not enough for a human being to maintain their critical body temperature for very long. So, in summary, the freeze cycle has the cooler surface layer of water sinking and the slightly warmer water displaced by the sinking water then rushes in to become the new surface layer. And as the ambient continues to cool toward the freezing point and beyond, the lower parts of the body of water equilibrate at 4C, 4 degrees C, while the surface layers begin to freeze and float on the slightly warmer and denser 4 degrees C water below. Okay, we wish to show an idealization here of what we were just discussing with the formation of the ice at the surface. You'll see it's sort of a color-coded little video that shows the density decreasing with the color getting lighter. And as the density is decreasing, it's transitioning towards the solid phase and ice. So, upon the formation of ice, the crucial displacement of an immediately lower layer of water continues, but in an altogether different fashion. That is to say, we're not talking about a denser, cooler layer of liquid sinking now. We're talking about an actual formation of a layer of ice at the top now. So that displacement process of the layer just below, it occurs in a different fashion and follows Archimedes' principle now going forward once the ice is established. And Archimedes' principle says that the volume of the displaced fluid is equivalent to the volume of the object below the surface. And so in this context, the volume of water, of the displaced water, is equivalent to the volume of the ice below. That is to say, the volume of the ice below the surface. And so in this way, layer upon layer of ice forms at the surface in a cyclic fashion. And this is indeed a negative feedback loop with a temperature moderator. And the feedback stops when the displacement of surface water stops. That's the trigger. That stops the cycle. And of course, that is temperature dependent. So the important takeaway is that freezing occurs first at the surface, while the lower waters remain at a relatively constant temperature of 4C or 39.2 Fahrenheit. Because once established, the ice and any snow buildup acts as a sort of thermal insulator, preventing the 4C water below it from freezing, and thus the ice acting as an insulator actually damps the ice growth. And this is classic rule-guided negative feedback behavior that shows up all over the universe, not just in regard to water. So please consider the intentionality behind this design. If water behaved more normally, that is, by decreasing its density, that is, expanding with increased temperature, and increasing its density, that is, shrinking with decreased temperature, and if it had a solid phase denser than its liquid phase, then a large body of water exposed to a frigid ambient for an extended period would freeze solid, because there would be no sink-rise cyclic action at the surface and water displacement upon the formation of ice further. And so there would be no attendant insulating ice layer. So clearly the properties of water were tuned just right for marine life to thrive. So maybe it's a good place right here to think about our Lord's intentions. God said, let the waters abound with an abundance of living creatures, and let birds fly above the earth across the face of the firmament of the heavens, per Genesis 1:20. It goes without saying that if all the waters on the earth froze solid, it would be catastrophic for life in general, not just marine life. Water's peculiar behavior around the 4C temperature is a testament to the genius of our Creator God, and in no small way manifests an aspect of His glory, and praise be His name. Okay, so now we wish to discuss the very high specific heat capacity of water. We are going to introduce some technical terms and concepts now, but we'll try to explain each of them in an easy to understand manner so that everyone can appreciate the beauty and elegance of Jehovah's work as touching water. A drop of water contains billions of water molecules that are constantly on the move and whose formula is H2O. Two hydrogen atoms and one oxygen atom comprise a water molecule. Right here, oxygen and two hydrogens. This is a molecule of water. A water molecule consists of a polar covalent bond, as explained in a moment. And the molecule itself is bent into a V shape with the oxygen at the tip of the V and the two hydrogens on the other end. The angle that the V makes is certainly not accidentally, 104.5 degrees. Okay. Covalent means that oxygen and hydrogen atoms share their valence electrons. That is the first concept to grasp before we proceed. Water's atoms share their valence electrons, where valence electrons are those electrons that are energetically the farthest from the nucleus and are therefore more loosely held by the nucleus. The simple insight to be noted is that valence electrons are the ones that are most easily lost, gained, or shared by an atom. And with that in mind, the matter comes down to a question of stability. And an atom is stablest when its valence shell is chock full of electrons. Let us repeat that. An atom is stablest when its valence shell is full of electrons. That is the Creator's chemical stability rule that short callers all matter. And chemical reactions proceed in such a way as to achieve stability, and in general, nature tends towards stability, whether chemically as just described or otherwise. A related concept to grasp is that negative feedback drives stability in systems, be it atoms, molecules, matter, planets, or galaxies. Okay, so in satisfaction of the Creator's stability rule, as concerns water, oxygen desires to have 8 electrons filling its valence shell, but of itself can only provide 6 electrons. And hydrogen desires to have 2 electrons filling its valence shell, but of itself can only provide 1. So, in order to satisfy the needs of both atoms, they share their electrons. Now, I have sketched on top of this illustration here and please forgive my work of art here, but I have sketched the covalent bond. So I want to distinguish between these bonds, and so let's work right here. These words, what these words mean is this picture. Oxygen can only provide 6 electrons, 1, 2, 3, 4, 5, and 6. But it wants 8 in its valence shell to be happy, and so it needs a couple more, and that comes from the hydrogen. It provides 1. This guy provides 1. The hydrogen wants 2, so it grabs 1 from the oxygen. So the hydrogen ends up having the 2 that it needs, and the oxygen ends up having the 8 that it needs by way of this mutual sharing of electrons. That's what these words here mean. These words mean this picture. It is a picture of stability. That's really, I guess, at the higher level of thinking, this is a picture of stability. And that's what these words are saying. Please forgive my art, but this is supposed to be, the red here is supposed to be the oxygen atom. That's what this little O in the middle means. It's an O for oxygen. Not to be confused with these electrons that I'm trying to show around the perimeter. So it ends up, oxygen does end up with the 8 that it needs to be stable, to fill its valence shell, and the hydrogens end up with the 2 that they need. This is an ingenious, beautiful work of creation right here. So this sharing categorizes the water molecule bond as covalent. It shares electrons, means it's covalent. It's a covalent. The bond is covalent in the molecule. But ingeniously, here is the rub. The sharing of the electrons, and I should say the negatively charged electrons, it's important, it's an obvious point, but let's keep that in mind. The negatively charged electrons is not equal. The sharing is not equal. And this is what makes the water molecule a polar molecule, as explained just next. Water molecules are polar because oxygen is, quote, an electron lover, more so than hydrogen. Technically, oxygen is more electronegative than hydrogen. And so, as the water molecule forms, the oxygen atom pulls harder on the shared electrons than the hydrogen atoms do. And in this way, the oxygen side, or pole, of the water molecule becomes more negative relative to the hydrogen side, or pole. Put a minus sign here next to the oxygen. And I could do the same here, but this is getting a little cluttered, so this would be minus, this would be plus. Let's see, let's put it here. Same thing all throughout, negative, positive. Well, this configuration will charge the oppositely charged ends of other water molecules, like, for example, let's look at this. Okay, let's look at this molecule here. So this plus side and this molecule will want to attract. There's an attraction here. And that's all throughout the liquid water like that between all the molecules. Now these connections, these electrical attractions, they're weak, but keeping in mind that there are billions of them throughout the liquid water makes for a very tight network of connections. And these connections, these attractions here, They're called hydrogen bonds. So we had to talk about the covalent bond and the polarity before we could discuss this particular bond here. So we want to distinguish now between the two types of bonds. This bond is intramolecular. This bond is intermolecular. And the author of this illustration here is trying to show a couple of hydrogen bonds here and here. It would be the attraction would be this way, plus to minus. And I guess I could put this guy here. And so there's that attraction here. This sign, this is attracting this way, and this is attracting, this way. So these are the intermolecular bonds, these are the intramolecular bonds. And the covalent intramolecular bonds are sharing their electrons in this manner. Hydrogen bonds are a key design aspect of water, and they are manipulated by rules under largely negative feedback to effect the Creator's several purposes for water. Let's look at a few of these rules. Because of its low molecular weight of about 18 grams per mole, it's just kind of like saying 12 eggs per dozen. One would expect water to be a gas at room temperature, but the molecules are so tightly connected due to the prodigious number of hydrogen bonds that water remains a liquid at room temperature. That is to say, there is not enough heat energy at room temperature to displace the molecules far enough apart and for long enough to overcome the electrical effects holding the molecules together, though a scarce few do escape the liquid because they get kind of a sort of an added kick from the kinetic energy of motion of other water molecules. Remember, water molecules are constantly on the move. So water remains a liquid at room temperature is the point we all understand. We all know that. But this is obviously an extremely important property of water that has huge implications for all life, not least for human beings, seeing that 60% of the human body is comprised of liquid water. Now consider the genius of our Creator in the following. As more heat energy is added to water, its temperature increases because some of the hydrogen bonds are broken. Allowing the molecules to move about freely with an attendant kinetic energy proportional to the absorbed heat energy. When we say kinetic energy, that means energy of motion. It's the energy that attends motion. Upon cooling, the molecules slow down, and the average distance between molecules decreases, and the average time that they spend in one another's proximity increases. And this allows the hydrogen bonds to reform, and the energy that was previously absorbed and which caused a given bond to break, hydrogen bond to break, setting a given molecule into motion is released to the environment in keeping with the Creator's conservation of energy rule. But let's go over that again. What is important to note is that a water molecule absorbs heat, hydrogen bonds break, and consequently it moves about with a certain energy on the one hand. And the molecule releases or gives back heat when bonds reform upon cooling on the other hand. And that is what gives water its high specific heat capacity. Itself an amazing temperature regulating mechanism. Specific heat capacity is the amount of heat energy, this is by definition now, that 1 gram of a substance must absorb or lose to change its temperature by 1 degree Celsius. For water, this value is 1 small, that is non-food, calorie, or 4.184 joules of energy, where this 4.184 joules of energy, to get a feel for what that is, it's very roughly equivalent to the energy that's necessary to lift a 1 pound or 0.43 kilogram object to a vertical height of about 3 feet or 1 meter. Not surprisingly, the Creator designed water to have the highest specific heat of any liquid. And what this means practically is that it takes water a very long time to heat or cool. Heating and cooling of water as measured by its temperature does not happen suddenly. And this has significant implications for humans because being comprised largely of water, we're able to maintain a constant internal body temperature over against sudden temperature swings in the ambient. For example, leaving the confines of a warm house and going outside into the frigid cold. And no less marine animals are able to survive sudden, wide ambient temperature changes because the water around them doesn't fluctuate in lockstep with these ambient swings in temperature. Another consequence of water's prodigious hydrogen bonding is that evaporation, the process wherein water molecules escape the surface of the liquid, significantly cools the adjacent object that sources this heat. I should say this heat energy that kicks these molecules out of the liquid. And sweat, for example, which is about 90% water, upon evaporation cools the body as the body gives up the heat that's necessary for the evaporation of water. And this is a remarkably efficient cooling mechanism designed to work in conjunction with the skin, which covers the vast surface area of the human body. A little more detail here. Consider a sweat droplet at some elevated body temperature, which temperature is a reflection of the average kinetic energy of the molecules in the sweat droplet. These high-speed molecules in the droplet are the ones that can escape from the liquid into the surrounding air. And if there's any kind of a breeze blowing, it'll blow these molecules away as soon as they escape. And therefore, the chance of their re-entering the drop of sweat is, of course, very small. So, since the droplet is losing its high-speed molecules, the average kinetic energy of the remaining molecules in the drop must decrease. And this means that the temperature of the droplet must also decrease. And since the droplet is now cooler than its surroundings, including the skin on which it rests, it draws heat from the body, which warms the droplet back up again, increasing the speed of its molecules, which allows the evaporation process to continue at more or less the same rate. And so sweat droplets are an effective means of drawing heat from the body and releasing it into the surrounding air in the form of high-speed molecules. Now, the root mean square speed of water molecules at 30 degrees C, which is 86 Fahrenheit, and 100 degrees C, or 212 Fahrenheit, is about the same. It follows, therefore, if water molecules at 100 C have enough energy to escape into the gas phase upon boiling, many molecules at 30 degrees C, which is nearer the average body temperature, will also be able to escape. And what we see here at work is a feedback mechanism that drives the cooling action toward equilibrium. In this case, homeostasis of body temperature. Feedback, as always, is what drives and sustains the action. The rules, for example, the hydrogen bonding scheme or the heat of vaporization, so on, these guide the action. Now, another property of water related to the electrical polarity of the molecule. Water is a highly efficient solvent for other polar and/or ionic compounds. In fact, water is dubbed the universal solvent. Consider ordinary table salt, sodium chloride, as a simple example. Salt is an ionic compound where the sodium ion has a positive charge and the chloride ion has a negative charge. When added to water, salt dissociates, that is, it ionizes into sodium and chloride ions. As the negative end of the water molecules, that is the oxygen atom at the tip of the V, right here, this guy, throughout. It surrounds the positively charged sodium ions, and likewise, the positive end of the water molecule, the hydrogen atoms, surround the negatively charged chloride ions. And in this way, the salt is basically broken up into its constituent ions by the polar water molecule and comprises the solute, which is uniformly distributed within the solvent, which is the water. And as a solution, it serves its own role in our Creator's handiwork. For example, sodium is an electrolyte that regulates the amount of water contained in the human body. And no less, it has a role in the function of nerve impulses and muscle contractions. And the chloride is also an electrolyte that keeps the amount of fluid inside and outside of cells in balance and aids in maintaining proper blood volume and blood pressure and the proper pH of body fluids, and so on. Now, most chemical reactions in nature are carried out in solutions, and in that context, water is the most common solvent used by living things. And yet another example. Because the water molecule is a polar molecule, cohesive forces attract the oppositely charged ends of water molecules toward each other. We see this, for example, right here again. And this produces the phenomenon of surface tension, which gives water droplets their spherical shape, which become teardrop-shaped under the influence of gravity. As the force of gravity and the cohesive forces, they tug on the drop in sort of in opposite directions. Now, surface tension is also what allows, we've all seen it, insects to walk on the surface of water. Now, one must digress here, realizing, the Creator of the polar water molecule and its cohesive forces would have no trouble walking on water. And again, because a water molecule is a polar molecule, it attracts the oppositely charged ends of other molecules besides itself, giving rise to adhesive forces that allow mineral-rich water to climb from the roots of plants to their leaves, as the attractive forces of the polar water molecule to the molecules in the stem of the plant overcome the force of gravity and water's cohesive forces. Technically, this is a form of capillary action, and it is no small thing that the mineral-rich water is itself a function of the dissociating solvent power of water as it breaks down the minerals in the ground that become dissolved in the water that climbs the stem of the plants to its leaves via adhesive forces. We must keep in mind here that plants with altogether withered or missing leaves cannot bear fruit. So no polar water molecule, no adhesive forces, no fruit. Clearly, the Creator Jehovah's polarity rule, as evidenced by what we have shown here, this is certainly not a chance sort of thing, nor is it an accident, nor is it somehow an ad hoc afterthought, because there is laser-like intentionality serving a far-reaching purpose behind it. And now we would like to look at the amphoteric properties of water. That is, its capacity to act as both an acid and a base in solution and to itself. Water's amazing molecule can act as both an acid and a base. Technically, water is an amphoteric compound. When acting as an acid or a base to itself, oftentimes textbooks refer to this as autoionization, but this is a misnomer. Ionization is a result of negative feedback operating under specific purposed rules. In this case, one water molecule donates a hydrogen atom acting as the acid to another water molecule acting as the base. In this way, under feedback, water dissociates a small percentage of its molecules into equal numbers of hydrogen ions, H plus protons basically, and hydroxide ions, OH minus. Because of their hydrogen bonds with other water molecules, the hydroxide OH minus ions remain in solution, while the H plus protons are attracted to unionized water molecules and form hydronium H3O plus ions. This follows the relation 2H2O goes to H3O plus OH minus. And this simply says that a couple of water molecules hook up and produce hydronium and hydroxide. And this occurs throughout the liquid. The upshot, the takeaway, is that pure water is a solution that is both acidic, owing to the hydronium ions, H3O plus, and basic, owing to the hydroxide ions, OH minus, that are in it. So, when mixed with an acid, water readily accepts H plus ions and acts as a base owing to hydroxide reactions. And when mixed with a base, it donates H plus ions, protons, and acts like an acid owing to the hydronium H3O plus ions. Now, practically, since acids and bases release or take up excess hydrogens, which are protons, respectively, from their environs, and since losing or gaining protons alters the structure of molecules, proteins, the workhorses of cells, which require a specific structure to function aright, as discussed later, must be protected from acids and bases. And water does this by acting as both an acid and a base, as just discussed. This is another classic example of negative feedback continuously driving a system toward equilibrium stability. Okay, now a word about buffers. And we're going to be focused on this block down here. That block shows the buffer at work in human blood. It is the blood buffer. Human blood is comprised of a liquid, 55%, and solids, 45%, where the liquid part, called plasma, consists of water, salts, and protein. The solid part consists of red blood cells, which are made in the bone marrow, and contain a protein called hemoglobin, which carries oxygen from the lungs to all parts of the body. And it consists of white blood cells, which are part of the immune system and protect one from disease and infection. I guess I should say it helps the body to fight infection and disease. And then the solid other component in the solid part is called platelets, which are cell fragments that form clots and help stop bleeding. And besides all this, human blood contains a buffer of carbonic acid, H2CO3, right here. And also the bicarbonate anion, HCO3 minus. That's this part right here. And ultimately carbon dioxide right here. This buffer maintains blood pH between 7.35 and 7.45, where a value higher than 7.8 or lower than 6.8 can lead to death. Note that most biological reactions require very specific pH ranges to function aright. In this buffer, the reactants, the H+, which is essentially hydronium, H3O+, in solution, emanating from some acidic substance that entered the bloodstream, let's say vinegar or orange juice and so forth. And the bicarbonate, which is produced in the red blood cells. We're right here right now. These reactants are in equilibrium with the product, which is carbonic acid. This guy right here. Reactants and product. The term equilibrium means that no net change in the amounts of the reactants and products occur. No net change. So, simply put, what's happening is that the bicarbonate neutralizes the hydronium ions, forming carbonic acid and ultimately water and carbon dioxide in the second equilibrium down here. The upshot is that hydronium ions are removed, preventing the pH of blood from becoming acidic. Basically, pH is raised in this case. It's raised. So, in one direction, following the blue arrows, pH in blood is raised by producing more water and carbon dioxide. In the reverse direction, the purple arrows going this way, the reverse lowers pH as more bicarbonate and hydronium is produced. This is a remarkable, highly efficient two-way system and another classic example of negative feedback at work. That such a system as this came together by chance is ludicrous. And now finally to a discussion of water and the cell. Water fills cells at the molecular level to help them maintain their shape, where by the term shape we mean manifest pattern, in keeping with the patterns outlined above. Typically, cells are round, which round is a uniform shape, or elongated, also a uniform shape, or spherical. This is 3D and uniform. To effect this shape maintenance, the water filling the cell creates pressure, which by definition is a given force per unit area, that opposes external forces impressing upon the cell. The backdrop to be tucked away is that shape is crucial for biochemical processes to unfold aright. And not least, shape facilitates the formation of membranes surrounding cells, where every living cell is surrounded by a membrane. These membranes consist of a bilayer of molecules called the phospholipid layer. Excuse me, I meant to say the phospholipid bilayer. That has electrically polar heads and nonpolar tails, where the polar heads interact with the electrically polar water molecules. Thus they are hydrophilic, surrounding the cell and inside the cell, whilst the nonpolar tails attempt to avoid the water. Thus they are hydrophobic and rather interact with each other. Hence the heads end up oriented pointing toward the surrounding water, and the tails point away from any water. Okay, so the red ones here, those are the heads. They're polar, so they point toward any water, like here. The phospholipids want to avoid any water, so they're pointing away from it toward each other and interacting with each other. And down here at the bottom, we see the same thing as up here, the polar heads interacting with the water. And this is an ingenious utilization of the polarity of the water molecule to effect a certain function. So this bilayer that is thus formed, so there's one, and like that, and then the whole thing is called the phospholipid bilayer. So this bilayer that surrounds the cell selectively allows salts and nutrients to enter and exit the cell by way of protein molecules embedded in it, as shown down here. These guys. Cholesterol is also a phospholipid, and it fits in between the phospholipids as shown down here. It's yellow. And it influences the membrane's permeability and fluidity. So there are two ways that cells can get the cholesterol needed for the membranes, either by using food sources containing low-density lipoproteins, or LDL, which itself transports fatty acids and their derivatives, all alike insoluble in water, from the liver to body cells, including those in the arteries, where it can contribute to life-threatening plaque buildup. So therefore, the cholesterol plays a positive role for us in the cells, certainly, and yet, in excess, it can play a very deadly role, too. And the other way that the cell attains the cholesterol is by synthesizing it directly in the cell, within the cell. Perhaps the key takeaway for our purposes is that water helps cell membranes maintain structure. Without proper membrane structure, cells would be unable to keep important molecules inside the cell and harmful ones outside. And water affects DNA and proteins, the latter being a long chain of building block amino acids that must fold into a certain specific shape to function aright. And it is water that drives that folding, as different types of amino acids once again either seek hydrophilic or avoid hydrophobic interacting with it. There's some 500 amino acids in nature, but only 20 comprise the proteins found in the human body, indeed in all living bodies. Proteins, the workhorses of cells, provide structure. They receive signals, that is, feedback updates, and catalyze chemical reactions in the cell, besides many other functions. Without proper shape, proteins would not be able to perform these functions, and a cell, as also the human host, could not survive. And no less DNA needs to be in a certain shape for its instructions, that is, its feedback rules, to be decoded aright. Proteins that read or copy DNA can only bind DNA that has a particular shape. And it is water, its molecules, that surround DNA to support its double helix shape. Without this shape, cells would not be able to follow the rules decoded by DNA and pass them on to new cells, thus making human growth, reproduction, and indeed survival impossible. And that concludes the technical side of the material that we wanted to present. So let us now turn to the Word of God and appreciate His references to the water He created for us. In the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was on the face of the deep. And the Spirit of God was hovering over the face of the waters. It is possible that this verse moves from a matrix of elements to home, to literal water, mayam, and of necessity the negative feedback guided by water's various rules, themselves impressed on it and everything else under the heavens right here by the Spirit of God. And from all that stems the manifest properties of water we've been discussing. Feedback operating under precise, purposed rules. Can the papyrus grow up without a marsh? Can the reeds flourish without water? While it is yet green and not cut down, it withers before any other plant. So are the paths of all who forget God, and the hope of the hypocrite shall perish. It's a beautiful example of Hebraic parallelism here. And the answer is no. They can't. They need the water. This bespeaks of dissolved nutrients and capillary action. No nutrients, no life. No God, no life. Notice, while it is yet green and not cut down, it withers. The papyrus and the reeds, they belong in the water. That is what they were made for. And without that water, before any other plant, when these guys leave their environs that they were created for, they straightaway wither. And the comparison here is made to those. Actually, all of us, we're all made for God. And when we leave those environs, that relationship, we too wither. Probably it's fair to say that the family of faith withers before the rest, because after all, we're not in our environs when we're away from God and we forget Him. And what is the hope of the hypocrite? The hope of the hypocrite is pretension. Pretense. And in his pretense, the hypocrite is out of his element. Just like the analogy is drawn here to the reeds and the papyrus, if they are not in their environs, if they're not in their element. And why? Why is this? It is because that very important nutrition, the living waters and the bread of life are altogether missing. These are the quintessential nutrients. He binds up the water in his thick clouds, yet the clouds are not broken under it. Not least, this bespeaks the water cycle. Mechanically, things are of very light weight up to a point. Water vapor in the atmosphere cools and condenses on a dirt or dust particle, creating a cloud. And upon saturating with moisture, then and only then is the water released as raindrops with their characteristic teardrop shape owing to the force of gravity, which The force of gravity is competing with cohesive forces and attendant surface tension set up by the polar water molecule. Job tells us that God built a trigger point into clouds, namely saturation, and he clearly has in view the water cycle. Behold, God is great, and we do not know him, nor can the number of his years be discovered. He draws up drops of water, which distill as rain from the mist, which the clouds drop down and pour abundantly on man. As just noted in the previous verse, condensation is at the heart of the rainmaking, as also water vapor, and then the rain droplets upon saturation. And underlying the whole thing is the water cycle. Are these not terrific insights here given to Job by God some 4,000 years ago? Or who shut in the sea with doors when it burst forth and issued from the womb? When I made the clouds its thick garment, thick darkness its swaddling band, when I fixed my limits for it and set bars and doors. The sea issuing from the womb sounds very much like the fountains of the deep opening at the time of the great worldwide flood in Noah's day. Likewise, the attendant shifts in the Earth's lithosphere at that time surely set the bounds of the oceans. All right, the verse speaks of he who delights in the law of the Lord. He shall be like a tree planted by the rivers of water that brings forth its fruit in its season, whose leaf also shall not wither, and whatever he does shall prosper. A plant without leaves cannot produce fruit. Here, capillary action moves nutrient-rich water to the leaves. The nutrients are in solution owing to the polar water molecules breaking down the dirt at the roots. By analogy, our God is the water, the living water. His word is the nutrient. The leaves are his people. His spirit moves the nutrients to the leaves to produce fruit. Thus, his people flourish and prosper precisely because of him. As the deer pants for the water brooks, so pants my soul for you, O God. Thirst. Thirst is a God-given physical cue that the body needs water. It is a feeling that God built into us that we respond to in order to stay healthy. Thirst accompanies dehydration, and dehydration can be life-threatening, causing damage to the kidneys, heart, the brain. On a spiritual side, God built a different sort of cue into us, a spiritual one, a longing, a yearning for God, a thirsting for him, for his person, his spirit, his living water, which is his word. To ignore that cue is just as life-threatening as the former, only more so. for it can lead to eternal death. The king's heart is in the hand of the Lord. Like the rivers of water, he turns it wherever he wishes. This is it's a beautiful confession of acquiescence and avowal, in that it bespeaks submission to the will of God and avows God's power. No less, it bespeaks a certain trust that God's power is beneficent. The Lord will guide you continually and satisfy your soul in drought and strengthen your bones. You shall be like a watered garden and like a spring of water whose waters do not fail. Springs occur when water pressure causes a natural flow of groundwater onto the Earth's surface. The source is an aquifer, an underground layer of water-bearing permeable rock or rock fractures. The creator of mundane water and the provider of spiritual living water here promises to satisfy his own both physically and spiritually. He can do it. He knows how, and just as importantly, he wants to. And whoever gives one of these little ones only a cup of cold water in the name of a disciple, assuredly, I say to you, he shall by no means lose his reward. The water metaphor here is terrific. This verse is spoken in the context of someone being Jesus' follower, as though blessing him. A cup of cool water in a dry and parched land, thus blessing a disciple as they do their work for Jesus, thus keeping them hydrated that they faint not carrying out that work. For the environs are ever so parched, and thus parched seek to wither their leaves, the disciples' leaves, and thus their fruit for Jesus. Jesus answered and said to her, if you knew the gift of God, and who it is who says to you, give me a drink, you would have asked him, and he would have given you living water. The woman said to him, Sir, you have nothing to draw with, and the well is deep. Where then do you get this living water? Are you greater than our father Jacob, who gave us the well, and drank from it himself, as well as his sons and his livestock? Jesus answered and said to her, whoever drinks of this water will thirst again. But whoever drinks of the water that I shall give him will never thirst. But the water that I shall give him will become in him a fountain of water springing up into everlasting life. Jesus gives us living water. How fitting. The creator of water imparts the living water, which is the Spirit of God. That is the living water that ever satisfies one's thirst, nay, satisfies one's myriad thirsts. On the last day, the great day of the feast, Jesus stood and cried out, saying, "If anyone thirsts, let him come to me and drink. He who believes in me, as the Scripture has said, out of his heart will flow rivers of living water." This he spoke concerning the Spirit, whom those believing in him would receive, for the Holy Spirit was not yet given because Jesus was not yet glorified. And such a one, out of whose heart flows living waters, in turn is one through whom the Spirit of God may spiritually hydrate, through whom the Spirit of God may spiritually hydrate others. And here we wish to address both verses. And he said to me, "It is done. I am the Alpha and the Omega, the beginning and the end. I will give of the fountain of the water of life freely to him who thirsts." And the Spirit and the bride say, "Come." And let him who hears say, "Come." And let him who thirsts come. Whoever desires, let him take of the water of life freely. Let us hear Jesus here speaking. He who consummated the works of God with humankind at Calvary. He is the eternal one, the agent of creation, the mind behind water as we know it and appreciate it down here in the land of the living. And none other than He is the one who gives us the water we need for eternal life and satisfaction once and for all of our greatest thirst. Praised be His blessed name, even Hudo's own Jesus. Amen. Christ bless you, dearest friends.